effect on the performance of the vehicle dynamics of a vehicle, under a broad range of operating conditions. So this can include, handling and ride and durability and chassis controls as well. And there's a broad range of different tire models within Adams, and we're going to just touch upon those tire models. But the focus, again, like I mentioned, is going to be on the PAC2002 and FTire. And it's important to have an accurate tire model. And these tire models usually, for the most part, need to be populated by test data on the tire for the tire model to be accurate. And we'll touch upon that as well, about fitting tools and tire tests as well. Again, the two most mature tire models are the PAC2002 and the FTire model. And again, applications for these tire models include handling, ride, chassis control, and durability. So to touch upon the tire models traditionally fit under certain categories. There's the physical tire model, which includes a few tire models here that you can see, FTire being the most mature. There's the empirical tire models, which are formulated with the Pajenka tire model, magic formula, as it's better known. And the PAC2002 is the most mature tire model under the empirical tire models. And there's plug-in tire models, there's special tire models like soft soil, and there's also aircraft tire models that we support in Adams. So with the applications of these tire models, with the PAC2002, which is listed here in the first column, it's best really in handling for prediction of vehicle performance. But the PAC2002 with the belt dynamics, which is the second column shown here, it really does a really good job with handling, ride, and chassis controls. It's also pretty good with durability as well, but it's not the best. The best tire model for durability, which you can see here, is the FTire model. It has very good prediction of durability. It can handle higher frequencies, which we'll talk about it a little later. And it also can handle handling, but it's not the best for handling, like the PAC2002. But it's second to the PAC2002 for handling. And then I mentioned that the roads that are used to interface with the tire models play an important role with vehicle dynamics predictions. So having an accurate representation of the roads is also very important. So the Adams tire roads that we support here is the 2D road profile, which is traditionally a flat road, but it also has superposition of road obstacles. So you can have like potholes as well in the 2D representation, or bumps. And then also the more accurate road representation is the 3D roads, and these are the Adams tire 3D spline road and the 3D tire shell road as well, or the meshed road as it's better known. And then there's the CRG road, which is an open source for OpenCRG, which measures the road data. So they use like a laser to go over the road profile and get measurements of the road to represent the CRG. And then there's the RGR, which is a road that's also measured data, but it's a different format that COSEN, which develops and supports FTire, has as a road profile. So now the next section, the other important part is the road to tire contact. So by default, the tire models use the 1-point contact, but what's even more accurate is the 3D equivalent volume contact, where the road is defined with shell elements, like we mentioned earlier before in the last couple slides, and the tire cross-section profile contact, which is more for motorcycle tires, is also a very accurate road profile for contacts, and the 3D enveloping contact, which is a tandem cam approach to enveloping the obstacles, the bumps, or the potholes, or the different rough surfaces in a road that are represented in this enveloping contact. So now going to the PAC2002. The PAC2002 slip force model is a Pajenka formulation, or magic formulas as better known, and it's a linear transient model, which with tire relaxation for up to 7 hertz, and it's a basic handling model, but it can also do such things as non-linear transient models with contact mass up to 1500 hertz for chassis controls, and they can also handle 3D enveloping contact and belt dynamics. So it uses the rigid ring approach for the belt dynamics, and it's accurate up to 60 hertz. So the belt part is defined in Adams' model is really beneficial for statics, Adams' linear, and visualization, but it also has some additional benefits in the tire model. It can handle inflation pressure influences in the tire, and it can also handle like parking effort and aligning torque due to the parking effort for turn slip as well. And it also handles wheel bottoming, which is the impact of the rim to the road. And it also handles friction ellipse options for combined slip. And lastly, it's very good for DOE support. So you can do a lot of design of experiment with the tire model for the PAC2002. Within Adams' car, we have a fitting tool, a tire data fitting tool from Test Data for the PAC2002. So you can fit your tire test data and generate a PAC2002 tire model for vehicle dynamic simulations. So now on to FTire. Right now, it's one of the most comprehensive software packages for tire dynamics simulations in the market. It's a highly accurate physics-based 3D nonlinear tire simulation model, and it's developed and supported by COSIN Scientific Software, which I believe is headed out of Germany. Correct me if I'm wrong, Jan, later on. It covers both stiff, deformable, and time-variant road surfaces. So that means it can do the 3D enveloping, and it can also do soft soil pretty accurately as well. So it supports that, and it also not only does it support rigid rim models like the PAC2002, but it can also handle the flexible rim models as well. So it also has its own embedded pre and post processing tool for road data and tire data as well. So again, as I mentioned earlier in some of the early slides in this presentation, it takes the physical approach to modeling a tire. It also has it's also valid up to and beyond 120 hertz. So where the PAC2002 is really accurate to about 60 hertz, the FTire model takes it to to 120 hertz and beyond, which one of the reasons it's better at durability analysis than the PAC2002. It can handle the rough road surfaces much better than the PAC2002. But the PAC2002 is also not a bad model to use in that rough road comparison. Inflation pressures are able to be changed in the FTire model as well. Rim impact possible, like the bottoming, wheel bottoming like it is in the PAC2002, is also available. But some of the other things that are available that are not in the PAC2002 is the thermal model option and the tire wear model option as well. And then it also, like I mentioned, has the soft soil model option in there. And like the PAC2002, it supports the design of experiments as well. And one of the good things that COSIN has is its own post-processing, so you can visualize the tire model. But Adam's post-processing tool also has support of this post-processing with FTire as well. So you can do the post-processing animation within FTire in Adam's post-processor. So just as PAC2002 has its own fitting tool, the FTire model has its own fit tools for test data. So it has tools for processing the identification and validation of geometrical, static, steady state, handling, dynamic, and modal data from tests, and it fits that into the model. And it has an automated way to measure the data and recognize with conversions, format conversions as well. And it also has an automated footprint comparison, cross-sectional geometry import, and it has a stiffness determination for radial, longitudinal, lateral, torsional, cornering stiffness, pneumatic trail, and slip stiffness as well. And it's automated static and steady state validation by time domain simulation. And a dynamic identification using least square fits of cleat tests. So it uses a number of cleat tests, longitudinal cleat tests, lateral cleat tests, and incline cleat tests to not only in the time domain but in the frequency domain to determine the properties of the tire model. And then you can fit using the COSIN fitting tool into the virtual model, so you can run your vehicle dynamics simulations with high accuracy that the tire model brings with it, and get some good performance predictions for your vehicle dynamics simulation. And in conclusion, what I like to say is that Adams Tire supports a large number of tire models. We touched upon those. Again, what we focused on in this webinar was the most mature of these tire models are the PAC2002 and FTire. And again, these applications that we can run these tire models through with the vehicle, these vehicle dynamics models include handling, ride, chassis control, and durability. And again, one of the things that we also can do as a company, MSC, we work with Virginia Tech, CalSpan, and Smithers to test tires and also do the fitting of the tires within our tools or within the COSIN tools to predict these tire models and get a quick development of the users' development of tire models and vehicle dynamics models to impact their designs in the simulation world and also in the physical world. So OEMs as well as tire manufacturers can get these tire models as well as these vehicle models out into production a lot quicker. And with that, I'd like to end the webinar for the presenting portion of it and hand it over to Jan for any questions.
Right. Yeah. Thanks. Thanks, Dimitri. So it was a great presentation. So we have Jan and Dimitri on the panel to answer any questions. I see quite a few that have already come in. We have about 12 questions right now. I'll give it a couple of minutes. If you have any questions, please post them either in the Q&A window or in the chat window, and Dimitri and Jan will be able to respond and answer your questions. So let's give it a couple of minutes. I'll collect all the questions and then we can have a discussion. All right, so let me start reading out the questions, and Jan and Dimitri, please provide your input. So the first question is from Ray Kruger. Ray asks, is there a way to interface FTire with a discrete element model like EDEM that already interfaces with MSc Adams? I guess the answer is yes. Dimitri and Jan, I'll let you expand on that. So the question is, can FTire interface with a DEM package like EDEM that supports a coupling with MSc Adams?
Yes, Jan, I think this is more up your expertise.
Yes, okay. FTire it can work with hard roads in the standard way, but it can also work with soft throw roads. I know that it can deal with a rather simple soft throw road that's based upon Becker and Warm technology. And but I know that they are also developing in the direction of discrete element roads, elements method roads. I don't know the exact status of that, but I think if you're interested in that, you should contact CoSyn, which is the company that develops FTire.
Yeah, so it supports the Becker soft throw formula, and it's working currently on the discrete element formula with EDEM. So yeah, just like Jan said, we should contact CoSyn to find out what the status of the development of that discrete element for supporting EDEM product.
Okay, so the next question is, what accuracy can be expected in durability model predictions by fitting models from FE models that tire manufacturers create?
Yeah, I mean, tire modeling is difficult, but measuring tires, that's even more difficult. And so I think the accuracy that you can expect for durability loads, I think it's for FTire, it's better than PAC2002, because the PAC2002 model is more focused on ride, not such large obstacles. And FTire is more capable of having those very non-linear, high-impact obstacles. And I think it will be more accurate for load durability, load prediction.
Okay, thanks, Jan. So quite a few questions, so I'm going to try and zip through these. So does PAC2002 durability analysis require the same level of physical characterization as FTire?
No, as I mentioned, the PAC2002 model is not as accurate as the FTire model for durability or very large impact of obstacles. And so the enveloping type of model that's in the PAC2002 is a kind of empirical filter that filters the geometry of the road and which then can be converted into a kind of one point of contact. And that works quite well to obstacles, maybe up to half of the tire, the sidewall of the tire. But for real high impact, like durability, when you almost reach the rim or even have impact with the rim, FTire will be more suitable.
Okay, thanks. And there's a question on what are the physical measurements that are required to build or create a Pacheco 2002 model with belt dynamics?
So for Pacheco 2002 with belt dynamics, then the type of measurements that you need in addition to the standard force and moment testing is the kind of cleat testing that you also have for FTire. It's less extensive. The test program is less extensive than for FTire. But the cleat testing is used in order to get the properties for the enveloping, so when running over a cleat, and also for the eigenfrequencies of the belt. And if you're interested in more detail in the online help of Adams, you can find example programs for this kind of testing.
Right, thanks, Jan. There's a question on the ability to handle raw tire data. Before we bring it into Adams, is there any pre-treatment of tire data that is required?
Yeah, it's difficult. It's difficult to say what you mean about raw tire data. The type of testing that companies do for handling is for lateral dynamics, or it's sinusoidal sweeps or flip angle, and a kind of braking test, and that data usually can be used to do the fitting. The main thing for example, the Pacheco 2002 and the tire data fitting tool is to get that data in TIDEX, in the so-called TIDEX format. And once you have it in that format, then usually those tools, also the FTire fitting tool, is quite easy.
Okay. So there's a question on NVH analysis. So from an NVH perspective, which tire model would be most appropriate?
Yeah, like I said, for NVH, for when you have obstacles that are quite high, so larger than the half of the sidewall of the tire, then it's better to use FTire, more accurate than Pacheco 2002.
Okay. Any input or insight on aircraft tires, Jan or Dimitri?
So can you repeat your question?
On modeling, so there's a question on modeling aircraft tires.
Yeah, but both the Pacheco 2002 and FTire can be used for aircraft tires.
Okay.
Of course, it's more difficult to get test data for those tires. But in that case, customers can use the tire data fitting tool or the FTire tool to do more kind of a guess what kind of properties, what kind of for the kind of measurements they need.
Okay.
And, I know that FTire also has a tool that's called FTire Estimator, and that can estimate tire properties based upon on existing properties for all the tires.
Okay. So there's a question about the Swift tire model. So how does the Pacheco model compare with the Swift tire model? Maybe in broad terms, if you could provide some input.
Yeah, actually, the Swift tire is based upon the same technology as the Pacheco 2002. They're both based upon the technology that Pacheco presented in his book, Tire Vehicle Dynamics. And so they do not differ much. It's not you cannot just exchange property file from Swift tire to FTire 2002, but the kind of approach with the rigid ring is more or less the same.
Okay. So there's a question about suspension systems. So can the PAC2002 and or the FTire models simulate any other kinds of suspension systems like with torsion bars?
Yes, you can use both models easily with McPherson thread type of suspensions. I mean, of course, it depends a little bit what kind of simulations you're aiming for, but all the usual kind of handling simulations and ride and durability and chassis control systems, they are supported with tire models.
Okay. Okay. So there's a question on maybe conversion between the two types of models. Can you generate a full PAC2002 model with belt dynamics based on an existing FTire model?
Yes, as a matter of fact, in the tire data fitting tool, you can even convert an FTire property file into a FTire 2002 tire property file. So if you start the tire data fitting tool, you can just import an FTire tire property file, and then it will generate a kind of virtual test data, which then will be fitted by the tire data fitting tool, and that will give you the FTire 2002 tire property file.
Okay. Okay. There are a couple of questions on the soft soil tire model. I know we didn't go into it in a lot of detail, but again, can you maybe elaborate on things like use cases?
So the soft soil tire model is a rather in Adams tire is a rather basic model. It's based upon the development Becker and Wong technology. It can deal with the kind of roads that you already have in Adams, the kind of same kind of format. But you will need to add some parameters that for the properties of the soil, and those kind of properties, those are just the well-known properties that Becker and Wong describe in their papers. And once you've done that, then you can run simulations in Adams, rather basic handling simulation with the soft soil. It's not a very, I mean, it's still a rather basic model. It's not very advanced. It will give you a rather good first approach of vehicle behavior on soft soil.
Okay, thanks. Jan. So there's a question on the FTire model. The question is the FTire model able to simulate time-varying inflation pressures?
Yes, it is. It's possible to change the inflation pressure during the simulation with that.
Okay. There's a question on data for tire parameterization. The question is do major tire brands readily provide the parameterization or characterization data for specifically the FTire model?
For the FTire model,
Mm-hmm.
Yeah, I don't know exactly what tire manufacturers exactly can provide with respect to data. I know that the kind of handling data for handling type of tire models, that's more or less common sense, but for the high frequency data for belt dynamics and enveloping, that is of course more difficult to test. And I think they have a lot of equipment to do testing, but of course their testing is mainly focused on developing tires and not on providing such kind of data. There are a lot of other companies that can also do this kind of tire testing.
Yeah, with my experience on tire manufacturers, they'll provide some basic Pajenka parameters, magic formula parameters. But anything above and beyond that, like FTire, there needs to be a separate test done to provide those parameters that usually are requested by car manufacturers or truck manufacturers or construction company manufacturers as well.
Okay. There's a question on automated stiffness determination with an FTire. So should this be done using tools that Coulson provides?
I'm not quite sure if I understand the question. Can you repeat it once more?
Yeah. So the question is, let me read it as it is. The question is, how does the automated stiffness determination with an FTire work? Should we be using Coulson tools for, I guess, automated stiffness determination?
I mean, I would say yes.
Yes, in the Coulson tools you can change properties of the FTire. If you have an FTire property file and you want to change something in there, then the best way is to use the Coulson tools and not just edit the file, because it needs also some pre-processing. And so if you want to know something more about the stiffnesses of a tire or want to change something in a tire, then you should use the Coulson tools.
Okay. I'm going through the list here. Give me just a second. So there's a question about the difference between the PAC2002 Belt Dynamics model and the Swift tire model. So I guess you did talk about these two models, Jan. So the question is, as far as the user is concerned, both work on the concept of rigid ring belt. So is there any fundamental difference between the two tire models? And I think you mentioned that is not, right? So the Swift
No, it's not.
Yeah.
No.
Okay.
The basics is the same.
Okay.
Yes. And so here I see a question that someone wants to convert an MS Swift tire property file into a PAC2002, and actually that's also possible. Like I explained for the FTire, you can convert an FTire tire property file using the tire data fitting tool into a PAC2002 tire property file. But actually, you can do the same for MS Swift tire property file. You can also convert to a PAC2002 tire property file using this tire data fitting tool.
Okay, thanks. So there's a question on linearized models. So the question is can you generate a linearized model from PAC2002 with Belt Dynamics for use in frequency domain analysis?
I don't know exactly what I mean by linearized model, but actually in Adams you can use the full linearization package in order to linearize your full vehicle model. So that is all supported also with FTire, and so you can do calculations in the frequency domain.
Okay. Is FTire capable of simulating the response of the vehicle to tire blowouts? So extreme events, I guess.
Yes,
like tire blowouts.
yes. FTire it can simulate the response of a tire during a blowout of a tire.
Okay.
So.
So let me go to the chat window. There are quite a few on the chat window as well. We'll try to cover as many as possible. So, Ian, there's a question on fitting a Pacheco model to a FTire model with maybe a high degree of accuracy. Maybe so. This is a pretty technical question, but any best practices in approaches and settings that one should use to get the best possible fitting from of a Pacheco model to an FTire model?
Yes. So if you do a conversion of FTire model into a Pacheco 2002 model, you can use this tire data fitting tool, and we try to automate the process. But of course, it can always happen that that you want to improve the quality. So the best way is to after each type of fit to check if controls the conversion of that model, because during the conversion the FTire is used to generate more or less visual tire test data, and then you can make comparisons of the converted Pacheco 2002 model with the data that was generated by FTire, and and then you could repeat the step by setting boundaries or having different starting values. In general, that is not a problem for the handling type of parameters. Sometimes for the enveloping, you need to adjust a little bit the starting values or the belt dynamics, but for the first part of the conversion, that works quite well.
Okay. Thank you. There's a question on thermal impact. Does PAC2002 include thermal impact?
No, it does not.
Okay. Let me go through the list of questions one more time and just make sure I haven't missed anything. So there's a question on NVH. So we did talk about the applicability of tire models to NVH simulations. So the question is, can the results from the Adams FTire model be interfaced with NVH simulations?
Yeah, I'm not. I don't know exactly what they mean with this question.
Yeah, I'm not sure if it's within Adams or outside Adams. So I'll reach out to the user and get a little bit more detail. Yeah. So there's a question on how intensive the fitting process is, Ian. So the question is, how long does the PAC2002 fitting typically take, including cleat?
Yeah, that may be up to half an hour maximum.
Okay.
Of course, it depends on the kind of platform that you're using, but for that fitting, you can use multiple threads on your machine, so that will improve the performance quite a lot.